Hey there, Python programmers. Today we're going to keep working on our tic-tac-toe game and we're going to tackle this computer move method. So we only have two more methods left in our tic-tac-toe game, the computer move and the minimax. So again, we'll take on computer move. What computer move is going to handle is similar to human move, where that handles a single move for a human. We're going to go ahead and have computer move handle a single move for the computer. And what it will do, pretty much, again, we've got our tic-tac-toe board here, and let's assume that the human player has played X. So what does our computer need to do to make its move? Well, our computer is going to iterate through our game board, basically going to each space, looking at that space. If the space is empty, the computer is going to call the minimax and play out the entire rest of the game as if they would move in that space. And then ultimately, that'll give a score for, hey, did this move eventually lead to a win, a tie, or would it lead to a loss? And it's going to do that for every one of these squares. Now, it won't do it for the center one because it's going to check, hey, is there already a move there? And again, we see that there is already a move in X, but it'll do it for all the others. And then once it's pretty much played out the entire game on each individual move, it's going to pick whichever one was the best choice and make its move there. So that's what we need to code out together today. Let's dive in. For our computer move, we always want to set up our docstring first, and this is going to be a method to control a computer player, and it's going to be using the minimax, we'll call it method from below. So first of all, we're going to want to initialize two variables that we need. One we're going to call best score. So we're going to set that to something interesting. There is a concept of infinity and negative infinity, and Python does allow for us to do these. Again, how we have to set them up is to instantiate a float and pass a very specific string that is either negative INF, short for infinity, or just plain INF for positive infinity. This pretty much is the way to set best score to the absolute lowest value it could be ever, pretty much meaning any other score we calculate is going to be better than this initial value. Because again, what we're going to want to do, as we mentioned, is iterate through our board, checking each one of the things. It looks like our board's a little messed up, so let me make a move real quick to refresh it. There we go. So again, from the very start, we have to make a move. We want this value to be the absolute lowest value so that there has to be at least one move that's going to be higher than that. So we're going to use, again, negative infinity, basically meaning negative as far as you could imagine. So even a value of 0 is going to be greater than. We also want to have a best move variable. This is pretty much going to be like the index of where we're going to move. And we want to set that equal to none from the start, because again, we don't want these to have values. These need to be assigned new values. Let's call it best move, not best move, based on what we're going to do next. Since we know we are iterating through, a finite object or pretty much our board here, and again, I don't think we need to keep looking at the board, we can do a for loop. I do want to do a for loop where we have both the index and the move accessible to us. So we're going to use our favorite built-in enumerate, and we're going to enumerate our self.org. Because again, we're going to need to look at two things. We're going to need to look at, let me make one more move. We're going to need to look at the actual value that's at the board. Again, is there an X or O there, or is it an empty space? But then again, we're going to have to keep track of the index that has the best score. So again, as we're going through one by one, maybe our first, move space had the best score, but we still have to check all of them. So again, we'll set that highest score to 0 when we check this one. And if anything beats it, then we'd update that value. Pretty much a rather standard practice for how we're going to iterate through our board and make decisions. Cool. So first, we're going to want to check if our move value equals an empty string. Because if it does equal an empty string, we actually want to make a move. If there's an X or Y there, we just want to keep on going. So we're going to actually have the entirety or the rest of this for block inside this if statement. Because again, if it's an X or an O already, we want to skip it. We can't make a move there. There's no reason to even try figuring out what a move like that would look like. So now what we're going to want to do is actually like make a move. So we're going to say sell dot board, add our index, and we definitely need to spell board right here. Now this is where we're going to use something fun. We're going to use a ternary because, hey, depending on which player our computer is, like we want to make it so that our computer could be X or O, and we're even going to make it so that two computers can play each other, which will be a lot of fun. But we have to have a little logic of, hey, which turn is it? Is it X's turn or it's Y's turn? If we remember, we literally have done this right above here is the same context or our code of, hey, if the player turn is 1, we're going to need it to be X, but if it's 0 or player two's turn, we obviously do want it to be that 0. So what this will do is actually make a move in our board. Don't worry, we're not going to leave it that way, but again, we are going to need to do this. Now, the next thing is going to be, we are going to get a score. And this is where we're going to call our self minimax algorithm. Again, this will be in our next lecture, coding that one out. But we're going to need to code it. And just for now, I'm going to do 0 and false. Minimax is going to need two parameters. One is going to be a starting depth, and the other is going to be a true or false based on telling minimax, is it minimizing or maximizing? And again, we're going to go into that in way more detail in our next lecture. So this will be where we call our minimax. And remember, our minimax is what's going to go through and play out the entire game based on if we choose X. So like the first thing, we're going to put potentially we put an O because again, our computer in the game we set up is player 2. So it's going to put an O in the first space. I think our first space is filled up, but again, it's going to put an O here, and then we're going to send the board to our check score or check outcome method, and it'll tell us, hey, did we just win? Did we just lose? Is it suddenly a tie? Or did nothing happen and we need to keep playing? So that's what we're going to get out of there. Once we've called the minimax and it's played out that whole game and returned to us the score value of choosing to play there, the next thing we're going to want to do is now reset the board. So we'll do a cell dot board at the same index, and we're just going to set it back equal to our empty string. And like we hadn't even moved there because this isn't where we pick where to go yet. Again, we have to try every open piece to see if that move is going to be the best move or maybe the next board piece. Again, we have to try them all. Now our computer does it so fast. Again, we're not going to notice, but this is again this is what we'll need to implement. After we've now reset the board, because again, this is taking the state of our game right back to where it was before we made this play, now we just need to check, is this score going to be the best score? And if it is, we need to remember that, but then we also need to remember the index of where the best score was. So if our score is greater than our best score, and again, the first time we even run this, it pretty much has to be because there's going to be no way for us to have a score from the minimax that wouldn't be higher than negative affinity. So again, no matter what, this logic will make a move for us. It's just we have to check all of the possible moves to find out what the best one is. So if the score coming back from Minimax is better than this best score, two things we got to do. We've got to now set best score equal to the new score. And we want to set best move equal to whatever index this best score was at. Cool. Four. Yeah. All right. So again, after we've done that, we're going to want to let the for loop continue. So we don't need anything else in our for loop. Once the for loop has completely run, it's gone to every single space in our board and checked if that is the best move. Now what we're going to want to do is actually make our move. So we'll do self.board that. Now this is going to be our best move because that will be whatever had the highest score, and that'll be the index for we want to make this best move. And then we're going to need our same ternary logic as above. Again, depending on which player's turn it is, we're going to want to actually record an X or an O. This is all we really need to actually complete the functionality of best move. But there's one other thing I want to do, and that is pretty much we want to do this for two reasons. It's going to make the gameplay a little more fun, but also if we have two computers playing each other, they're both X and O, which our game will allow, it's going to go so fast, you're not even going to get to see the game play out. So we're going to want to put a pause in. And we'll also want to do an F string where we say something like computer player, and then we can do self player turn, because that will report which player is currently making that turn, is making their MLVE, boom. And then what we'll do is we will sleep for, I'm going to put in 2 seconds. So what this will do is each time a computer makes its move, it's going to artificially take 2 seconds. But again, it's going to feel like our computer's kind of thinking about the move. But also, like I said, if we have two computers play each other, it would go so fast, you would just see the last move and who won. We want it to kind of be like a fun, you're watching the computer make one move and then it's making the next move. So putting in this sleep and this little prompt here is just, again, it's going to add a little and make playing the game more fun. Cool. With that, that's all we're going to need for our computer move. We only have one thing left, and that's our minimax algorithm. So we'll tackle that in the next video. Again, like and subscribe if you haven't. Hope you're enjoying the tic-tac-toe game, and I'll see you soon for our last video in the series.